All right. Well, thank you guys, everybody, for showing up, participating. We are thrilled to have you here. We are going to be going through, my name's Justin. I'm the Director of Marketing for Kitech Automation. We're going to be going through one of the full line build outs that we're working on right now. And we've got Baha, who is one of our main robotics engineers. He's a genius, and we are honored to have him going over the design that he's put together and how it all runs. So with that, I'm going to turn it over to Baha. As you guys have questions, please feel free to unmute yourself or chat them into the box. This is not an opportunity for us to talk at you. We're looking for some interaction and make sure it's a valuable investment of your time as well. So with that, Baha, take it away.
For sure. Thank you, Justin. Thank you for the introduction, and thank you guys for attending. As Justin mentioned, my name is Bahadur Musavi. I'm the Director of Robotics at Kitech Automation. At Kitech, one of the, I guess, major areas of interest for us is end-of-line packaging and palletizing, and that's what we're really good at. So basically, if you've got products coming out of a freezer or an oven, we take it from there all the way to having it on a pallet and wrapped for shipping purposes. So that's the area that we play in. We are working on a project at the moment. The design phase of it is almost over, and we're going to be delivering the system in July of 2021. We thought that's a good opportunity to dive into that and give you guys a little bit of an idea of the kind of things that we do and how we do it and all of those things. So at any point, if you've got any questions, please do let me know, and we'll start focusing on that. I do want to mention this to you that I have a few different things that I want to show you. So we're going to be starting with this animation over here. Again, as an animation, it's just visually pleasing. It's not necessarily accurate, but it gives you an idea of the whole story. We're going to look at the 2D model of the system. We're also going to be looking at two specific portions of it on how we're trying to solve an issue in this case. So you're going to see quite a bit of how this all flows together. The customer that we have, they specialize in making samosas. If you don't know what samosas are, they're absolutely delicious. You should try it. There are some small Indian treats. They're usually triangular shaped, and the ones that we're dealing with are about 2 inches in height. So that's what we're dealing with over here. We are getting them coming out of an oven, completely randomly, completely all over the place. They're not as shown in this animation over here. So they're all over the place. What we're doing is that we're de-elevating it from the freezer, and we're shaking them so that we're singulating them. We're using some singulation tactics over there as well so that they're singulated. And then they're fed into this robotic system that you see, which is a high-speed robotic system. Uses a vision system and Pickmaster, which is the software that we're using over here to grab these random samosas off of the conveyor and put them in specific formats. So we have 12 packs and 15 packs that the customer is looking for. So this is the 12-pack format that you see. And once we do that, once we grab these samosas and put them in specific orders of 12, this is exactly what they're going to look like. There's no tray or anything underneath it, but we're feeding this all the way through an inverted flow wrapper. And at the end of it, they get into bags that you see. They're not vacuumed bags. There's actually some air in there, and that's what the customer wanted to have. But as we come out of the flow wrapper, what you saw, that's all in the sanitary area. I'll put the model up and we'll go over that as well in a little bit. That's all in the sanitary area. And then once the products are in a bag, they go into a different room, which is the packaging site. And this is the packaging site as you see it. So the bags come out, they get into a carton using a cartoning machine, and they get fed to a case packer. But before going to the case packer, we have to stand them up in groups of 6 8 or 12, depending on the recipe that we're running. And then it's presented to a robotic case packer, which grabs the whole roll as a whole and puts it into the case. Once the product is in a case, it goes through a case sealer, gets sealed, and then it's fed to a robotic palletizer. As you can see, there's another line just behind us as well. So this is the samosa line. There's an entree line just behind it as well. And we're using the entree line. We're using the palletizer to palletize both the entree line and the samosa line over here. So quickly jumping into more engineering discussion. This is the actual layout of the building. All of this equipment is the equipment that we just went through and we're supplying. So we're taking over from this freezer out here. We're de-elevating, singulating the products and feeding it into the picker cells that you saw. Just want to quickly show you a more realistic view of the picker cells and how that works. So basically the 4 robots and the vision system, this is how they work together. This is an actual simulation, so the rates and everything are correct. We're dealing with picking about 600 pieces a minute in this scenario, which translates to about 850 kilograms an hour of production. By the way, this is a 24-hour operation that this group is going to have. So yeah, this is the actual simulation of what's happening over there. So as you can see, specifically these robots are capable of doing load distribution between each other so that they basically do the same amount of work, and they're basically working with each other. It's not like the first one is going to grab as many as it can and then the last one is going to sweep everything that's left. They're actually working with each other and they're distributing the load between each other. So yeah, jumping back into this 2D drawings of that. Again, the picker cells put the samosas in 12 or 15s and feed it into this bagger machine that we have over here. It gets bagged and then it goes to this cartoner. This wall over here is basically between the wash down area and the packaging area. So everything over here is built, washed down, and completely sanitary. Things over here are not necessarily sanitary products; they're all wiped down machines. So once we go into that room, we go through this cartoner. All the bags are put into a carton, and then they get fed into this case packing robot. We've got a case erector over here erecting the case, sending it to the case erector robot. And then it goes to the case sealer. I do want to show you basically how this works, where we are grabbing the cartons and standing them up and presenting them to the robot. So this would be the concept of how that works, basically. So there's an indexing conveyor that's standing these cartons up. It gets fed into basically a pusher over here. The pusher places it on this table. We're not going all the way into the carton exactly. We're putting it in on this table, and then the robot comes and picks it up from that table and puts it into the case. Now, this other line that I mentioned to you that we have, the entree line, they are not automating basically the bagging portion of that yet, but they are putting it in a cartoner. And then once it goes to that cartoner, it then gets transferred to another case packer. This is a higher speed case packer. We're doing those flat top rather than standing up. So we're putting, again, the same way. We've got cases coming over here. We're elevating this conveyor over here and then de-elevating it down and then feeding it into the case packer. It grabs the cartons, put them into the case, exactly very similar to this, and then goes through a case sealer again, and then gets to the palletizer. So this product over here, this is one of our lowest footprint palletizers. It's designed for 2-line in, 2-line out. And basically the way it's built and designed is that you can interact with the robot. This is in cases where you don't necessarily want to wrap the products right away. So in this case, they don't want to wrap the products right away. They want to put it in a freezer and then come out and wrap it. And they don't really have a lot of room for major conveyance. So they have their operator coming in, grabbing the full pallets and getting it out and replacing that with another pallet. And for that to happen, we're using safe move technology, which enables the robot to know when an operator is in, and then the robot won't be working in that area where the operator is in, but it continues to work on the other side until the operator is out, and then it works on both sides. So yeah, that's the general overview of this project and what we're looking at over here. Are there any questions on this so far?
And I have not seen any questions come in. Feel free to unmute yourself or just chat with us any questions you have about this system.
I have a question.
Sure, go ahead, Annie.
And forgive me if I miss this. I notice your rate is 600 pieces a minute, and you have 4 robotic arms. If I saw, picking and placing, what is the goal? Obviously is probably 100% pick, but do you account for overflow to be recycled back to the beginning of the line that might not have gotten picked?
For sure. So 600 is, just so you know, on the high side. So the max production rate is 850 kilograms an hour, which translates to about 600 pieces a minute. But absolutely great question. So we did mention that. So there's 2 ways of doing this. One of them is a manual way. One of them is a fully automatic way. And the customer chose to go the manual way for 2 reasons. One of them is that we are checking for the right shape of the product as well. And if there's any burnt marks or anything like that on the product, we want to reject it. And our rejection system is basically letting the product just fall off the conveyor, right? So we don't necessarily want to recirculate what we're rejecting. So that's why everything goes into a bin over here, and then they get inspected before it comes back and gets recirculated or gets picked. Having said that, as you can see in the simulation over here, so you do see this guy basically waiting most of the times, this guy waiting most of the times. That's because, with 4 robots, we can achieve much more than 600 a minute. And this is a very confident, I think the robots are basically at about 65 to 70% capacity, the 4 robots. And that's basically the area we want to be. We don't want to overload them more than 80% of the times, I guess. So yeah. I hope that answers your question.
It does perfectly. Thank you very much.
Sure.
But recirc is something you can do, Baha.
Yes, recirc is. That was the second part of it. I did say one part of it is just leaving it go out there, but that was the customer preference on. We have some potential rejects, so let that fly off. We want somebody to come in and look at it and get a feeling of why we're getting so many rejected and so on. If there's burning or anything like that, but recircing is absolutely an option, and we've done that in the past as well.
Awesome, great question, Annie. Anybody else have any questions about this system?
What kind of, are you guys using pneumatic grippers, or is it going to be like a soft robotics gripper?
No, so soft robotics grippers are awesome grippers, and we've used them in several projects in the past. There is one issue over here, and that there's nothing available for multiple picks at the moment from soft robotics. So we're using, these are basically suction grippers, but the way it works is that as soon as it picks up the object, it it springs back a little bit, and it allows for us to go and grab the next one. I think I have a video of that somewhere. I'll actually have to dig it up and share it. But actually, Gerald, do you have that video